Today's problem, bottom view of binary tree. Difficulty is medium. Average time, 45 minutes. It's pretty long. You are given the root of a binary tree, and your task is to return its bottom view. Bottom view of a binary tree is the set of nodes visible when the tree is viewed from the bottom. There are multiple bottommost nodes for a horizontal distance from the root. Then the latter one is the level order traversal considered. All right. This is not well explained. I think they sort of assume that you understand what they're talking about. And why some nodes are visible and why some nodes are not visible. I'll try to explain that. But okay, a horizontal distance from the root. Okay. See, these trees, the way the trees are drawn is not proportional. Okay, so for example, the root here, the lines to the child node are longer than in this one over here, for example, from the two node to the two leaf nodes. Horizontal distance from the root, that's what these numbers are that are labeling the tree. So horizontal distance from the root, this child node here, the left node would be -1 from the root to the left of the root. This is 1 to the right of the root. Right. This is the 6. The leaf node is 2. A horizontal distance of 2 from the root. Again, it's not drawn proportionally. The line is shorter and it's at a steeper angle. Now this one, the 4 and the 5, the 4 is -2 horizontal distance from the root. The 5 is actually a 0 horizontal distance from the root. It doesn't really look like that in the drawing. You know, it looks like if you were looking up from the bottom, you could still see the root. You could see it past the leaf node, but really if it were drawn proportionally, the 5 node would be back here at a 0 horizontal distance from the root. So the view is 4, 2, 0, 1. I'm sorry, 3, 6. I'm sorry, no, 4, 2, 5, 3, 6. This one. Okay, yeah. So every horizontal distance is only going to have one visible node. Okay, again, on this one, it looks like, well, why can't I see the 14? You know, why can't I see the 3? Okay, again, it's the horizontal distance. So this goes out, the 8 goes out 1 to the left of the root, -1. The 3 is back here and is in fact a 0 horizontal distance from the root. It would block the root. It would then be overlapped by this 4, which would also be a 0 horizontal distance from the root. So that's the only thing that's visible. Okay. The 1 is actually 1 unit to the right of the root. Okay, so the 20 would go 1 to the left. I'm sorry, the 8 is going to go 1 to the left. The 3 is going to come back, and in fact, is going to be a 0 horizontal distance from the root. The 14 is going to go over and be 1 unit to the right of the root. The same thing is true of the 28. So if you're wondering, why can't I see the 14? It's because it is a 1 and it's covered up by the 28. So each, I guess what you could call vertical position. Is that right? Vertical position, horizontal. I guess you call it vertical lines if we were able to draw this proportionally and draw vertical lines through it. Or maybe the horizontal position, but each horizontal position is going to have one visible node. So we have one for -2, -1, 0, 1, and 2. Okay? All right. Number of nodes will be between 1 and 10 to the 5th, 100,000. Data, the data in each node will be between 1 and 10 to the 5th. Expected complexities, linear, O of n. That sounds right. I think we just have to visit each node one time. Auxiliary space, O of n. Yeah, we're going to need a map and a queue. A lot of companies seem to ask this question, some of which I've heard of. Topic tags, tree. Okay. Let's go. Well, let's go over the algorithm then. This queue item, all right? Well, Java actually has a class called pair. It's javafx.util.pair. I tried importing that, but it won't import. So we don't have a pair class available. So we have to, well, we don't have to. You could use an array for this, I guess, but we're going to create a class called queueItem, which is essentially a pair consisting of a node and a line. What vertical line is the node on? Vertical line, again, being these -2, -1, 0, 1, 2. Okay. Step 1, create a list to store the result. If root equals null, yeah, now I'm not sure why I put that in. Root can't be null, can it? No. Okay, yeah, we don't actually need that. Okay, for this, I don't think we need it. Step 2, create a map to store the view of the nodes based on their vertical position. So a tree map is a key and a value, but it stays sorted by key. Now that I think about that, I wonder if that messes up our O of n runtime, because tree map operations are actually log in. They're not O of n operations. But you know, I don't know how else. I'm not sure how else we would do it, because they do have to be ordered. Step 3, create a queue. We're going to do a breadth first search of a breadth first traversal of the tree. Everything in the queue is a queue item, and it's going to contain a node and the vertical line on which the node exists. All right. Next, initialize the queue by adding the root node. The root node is on vertical line 0. All right. Now we'll do the breadth first search. Retrieve the node and its vertical position from the front of the queue. All right, I'm going to need a pen for this. I hope I have enough room for this. 20. All right. I think so. I'll try to write small. All right, let me get a pen. That's white. No, I don't want white. Black. Oh, you know what? Let me use actually the other annotation tool. Is that not going to work? Oh, there it is. Show the toolbar and give me a pen. Okay, and then put this like kind of out of the way over here. All right, so here is the queue. In the queue, we are going to have the node and its line. So that is a 20 and a 0. All right. And then now we start processing the queue. Take the first item out of the queue. That is this one, 20, 0. Map, put. We're going to put the line, which is 0, and the node data, which is 20. All right, so that goes in here. I'm going to put it in the center of the tree map because it's going to, and I need to have it in sorted order. All right, process the left child of the node. Okay, left child. I'm going to erase this. Process the left child. If there is a left node, and there is, then we add it to the queue with the node and the line -1. Now the current line is 0. So what we're going to add to the queue is the left child of the 20. That is the 8 and -1. Okay. Now process the right child. Does the node have a right child? Yes. That also goes in the queue with the node, and I'm not going to put like a node. The only thing we care about is actually the value. Well, yeah, that's not true either, but I'm going to put the value. No, actually, I think that is true. All we just care about the data, 22 and the value, which is going to be line plus 1, 1. All right, we're done. Back up to the top, process the next node. That is the 8 node. All right, and in the map, we're going to put the line, that is a -1, and this is sorted ascending by key, -1 and 8. And we're going to put in the queue, let's take this out. The left node, there is a left node, so we'll put the left node, and that is going to be a 5 and line -1, that's a -2. Okay. And right node. There is a right node, and that is going to go in. That is going to be 3 and 0. Good. Should have started this further left. Next node, 22. All right. 22 and 1. Okay, 22. So, oh, wait. No, that's fine. No, can we process that and then put in the map that line or that node, which is at line 1 and 22. Okay, and we process the nodes of that node, children of that node. All right, and I'm going to redraw the queue over here. We've got in there so far, we have 5, we have -2, we have 3, we have 0. We are going to add the left node of 22, which is 4 and 0. We're going to add the right node, which is 25 and 2. All right? And then we're going to get rid of this. Okay, next node. Next node is the 5 and the -2. Okay, put that in the map. -2 goes here, 5 goes here. Add the children of that node. Oh, it doesn't have any children. All right, that's good. So we'll just take it out of the queue. Next node, 3 and 0. Okay, 0, well, that's already in the map. But if you do a put on a map, it either adds the value or replaces the value. In this case, it's going to replace the value. 0 is already in the map. So we will replace the value and then add nodes to the map. 3, all right, it has a left child, so what goes into the map is 10 and -1. It has a right node, so what goes into the map is 14 and 1. Okay, and this node comes out. Next node, 4 and 0. All right, so that goes into the map. Now 0 is already in the map, so again, that replaces the value. 0 is now 4. That node doesn't have any children. Okay, so we leave it as is. Let's see. Okay, and then pop it. It's out of the queue. Okay, gone. Next, 25 and 2. All right, so that goes into the map. 2 is new. So 2 goes down here with a 25. Add its children. 3. Oh no, the child. There's a left child, so we have to add that. We're running out of space. I'm going to squeeze it in here. That node is 14. Let's see, 25 and 2. The child is 28 and 1. Right? So 25 and 2 comes off. Next node, 10 and -1. All right, -1 is already in the map, so we replace the value. Let's see, erase -1. We're going to replace it with 10. It has no children, okay? So that comes out of the queue. Next node in the queue, 14 and 1. 1 is already in the map, so we replace the value. Place the value. 14. Okay, it has no children. Comes out of the queue, and the last node in the queue is 28 and 1. 1 is already in the map, so we just replace the value. All right. Now the question is that the right answer? So what we have here is 5, 10, 4, 28, and 25, which is correct. Now this right here takes the values out of the map and puts them in a list and returns the list. So I feel like that should work. We're going to go ahead and submit this. Actually, I need to get this back. Well, you know what? Let me do a quick sanity check. All right, that was all right. So we'll do a submit. All right. So that's it. Let's see. Final thoughts on this. A queue for a breadth first search. A tree map for keeping the nodes in sorted order according to their vertical line position. And I guess, I mean, maybe that is cheating a little bit on the O of N, and they have some other thing in mind. Okay, whoa, I'm not able to do what? Okay, no, you know what? I am allowed to do that, but okay. They don't say anything else about on the topic tag. So I mean, I'm gonna go with it. I can't think of another way to do it. All right, that's it. And we will, yeah, please like the video, subscribe to the channel, and we'll see you next time.